Hello, good morning. My name is Lily. I am a REST and EVM engineer at Astria, where I work with other engineers to build infrastructure for sequencing rules. And my background, I've been in crypto for about 2 years. Previously, I was a smart contract auditor, and before that, I was an operating system developer at Facebook. So I'm not really a academic, but I'm very happy to be here to hopefully get y'all's opinion on some of the stuff I've been working on. And today, I prepared for y'all implementation of DEX sequencing rules. Specifically, I've implemented a first swap auction for Uniswap v3 pools using TEEs, or trusted execution environments. And I did this because crypto has a problem, or crypto has many problems, but one of the problems is that block builders are a point of centralization, meaning that these entities that we did not necessarily give permission to can do things to our transactions, such as they can censor them, or they can reorder them with poor outcomes for users. And I would argue that block builders are able to do this because we protocol developers, L1s, L2s, and on-chain protocols have done a poor job of capturing all of the value that exists in the DeFi ecosystem. So for example, DEX liquidity providers don't benefit from the SEX-DEX arbitrage opportunity that they create. Instead, block builders are actually able to make a lot of money by doing this. And I would argue that this is the fault of protocol developers and that we could be doing better. And I want to talk to you all today about sequencing rules because I think sequencing rules are another potential solution that protocol developers can use in order to try to capture all the value that we're creating in the DeFi ecosystem. So the goals of this presentation, I would like to introduce sequencing rules so we have a common vocabulary about what I'm trying to talk about, and then I'll provide a proof of concept implementation to hopefully get you guys thinking about different ways that we can use sequencing rules to benefit users. And also, since this is more of an academic crowd, I'm an engineer, I would really like a feedback on just hey, this makes no sense, or hey, this is great. Yeah, so the agenda, I'm going to do a quick background on block building, then I'll introduce sequencing rules as a concept, and then I'll show you the actual implementation that I've prepared. So this is an Ethereum coded presentation. I don't think anyone from Solana is here. So blockchains, they are chains of blocks. And when we users sign transactions with our private keys, typically they flow into various mempools. Some are public, some are private. And block builders are able to extract or access these transactions and construct blocks. And block builders, they don't necessarily do this out of the goodness of their heart. They do this because they make money. Typically, the block that is worth the most amount of money is the next one that is added to the blockchain. And I don't actually have exact numbers about how much money block builders make. Hopefully, some of the further presentations today can provide that value or provide those numbers, but it is a substantial amount. So a good question is, where is this money coming from? And again, I would just like to argue that it's coming from the decentralized community. So I want to explore with sequencing rules ways that we can actually recapture this profit. So the idea is that instead of letting block builders decide the organization of transactions for different DeFi protocols, instead we let protocols define how they'd like their transaction sequence, and then we build blocks that actually respect that sequencing. This is currently a open question about the best way to actually go about implementing this. Some people thought that we can use eigenlayer to incent block builders directly. Today, I'm going to be showing you a TEE, or trusted execution environment, or trusted hardware SGX implementation, where the on-chain contracts are aware of the TEE that is supposed to be doing the sequencing. Or you can use new sequencing layers like what we're building at Astria. But the main idea is that we want to recapture the value that DeFi protocols are leaking and give it back to the decentralized community's users instead of block builders. So now let's get into the implementation. So what I built, again, is a TEE-enabled first swap auction for a DEX. I use a Uniswap v3 pool as the DEX. I'm pretty sure everyone at this point knows what an AMM is, but you put in token A and you get out token B. And block builders, they really like these because they're able to do decentralized and centralized exchange arbitrage on this to make a lot of money. And I would argue that that money actually belongs to the LPs. So the sequencing rule that captures this value is that the first swap should be auctioned, and that money should be sent back to the LPs of the pool. And I use a TEE to run the auction, and I'll get more into the specific architecture I used. Real fast, auctioning an AMM is not a new idea. Over the last 3 years, there have been many papers written about this. Some of the authors are in this room. What is new is using a TEE to run the auction. I don't think that's been done before. And the TEE provider that I used for this was Suave. Suave is Flashbot's new platform. It is a network of TEEs, and that has like really interesting programming model like implications. For this proof of concept, I just used a single TEE instead of just like the network. And what the TEE does is it enables confidential and secure compute. So I'm actually running a second price sealed bid auction, which is like you can't do on like public blockchains. And Suave is great because you can actually program it with Solidity smart contracts. So it's like for all the protocol developers out there, this is like extremely accessible like to them. So the architecture. Quick note, the repo is public. So if I go really fast or it doesn't make sense, the code is like somewhat documented. So the architecture itself, it consists of 3 new smart contracts. One is on Suave and the other 2 are on Ethereum. The 2 on Ethereum, they don't do too much. They just handle withdrawing the bid payment from the bidders and then also just like gating certain functions on the Uniswap pool. The functions that are gated are the swap function and then also like removing liquidity because for sequencing rules, we want to ensure that the state that the first swap operates on is like locked down from their previous block, just to make sure that the bidders get the execution that they were interested in. And so the flow of the system is that now bidders and swappers, they submit their bids and their swap transactions to the TEE contract instead of to like a mempool. And the auction itself, it runs once per L1 block, and it just crafts a bundle that is then fed to the block builders. So the bundle, if it's just an ordered set of transactions, and we're able to pay block builders to like include this in their blocks. So there's like some payment still involved. And the bundle itself is what is like the communication link between the off-chain auction and the on-chain contracts. So TEEs are kind of cool because you can like put private keys inside of them and they're able to like sign things. So that's how the communication works between the 2 different chains. So the auction, it will construct a Ethereum transaction with auction result and sign over it. And that's the first transaction in the bundle. And then the next transaction is actually the winning swap of the bidder. And all the other swaps are just like included in the bundle just for, I guess, UX. Because block builders, they don't have to like necessarily put the other swaps after the auction results. They could put them before, but then that would just revert, and that's like bad UX. So the Uniswap pool itself is like minimally modified. I only modified like about 8 lines of code. I did have to delete some events like make space. So the auction contracts themselves are like pretty generic and not specific to Uniswap v3. This is compatible as a Uniswap v4 hook. You just like gate again the swap function and then the remove liquidity function. And so the flow of the system over time is you want to run the auction like in between the different blocks. So yes, this diagram, like the time moves from top to bottom. And just like after like an Ethereum block lands, then you want your bidders and your swappers to submit their transactions to the auction in the TEE. And then after like a configurable amount of time passes, then anyone can like trigger the auction. And then the auction runs, selects the winner, sends the bundle to the block builders, and then the block builders hopefully win the block, and then that bundle is included on-chain. So it's currently running on Heleski and Wriggle. Heleski is an Ethereum testnet, and Wriggle is Suave's testnet. So this is just like a little Rust server I wrote, and it like listens for new Heleski like L1 blocks, and then like it has bidders like submit bids, then it triggers the auction, and then it just does this on loop. The bids are being like printed out, but those are actually private because it's like sealed bid because TEEs offer like confidential like private compute. So again, the repo is public if people want to play around with it. I will say that this is definitely a proof of concept. This is like kind of a bad design for Ethereum because it's like dependent on getting your bundles to the winning block builders. For the Heleski example, I was actually paying like a lot in gas to like ensure that the bundles I was sending were like were in the winning block. I was paying 0.5 ETH. That's like insane. I'm just like Heleski rich, so. The other note is Suave is like in development still. It's not actually running TEs today. I know there's some Flashbots people here today, so maybe they can like offer more insight into the timelines. I also like had issues programming the memory model. Right now, the bids, there's some latency before the TE knows when bids are submitted. So if you submit your bid too late in the auction, they might not be included, which is like, again, poor UX. And there's like a coding solution to this. I just like didn't have time to implement that. And then the auction itself needs to be more decentralized. Right now, this is running on a single TEE instead of like a network of TEEs, which Suave is. And the problem here is that if that one TEE goes down, then your like decentralized protocol like goes down, which is like not great UX again. And the other note is that the TEE is like a new like programming environment. Right now, like I'm getting the current time by calling out to like timenow.com, which is like not great. There's like there's problems with actually knowing the time inside of a TE. So you kind of have to like trust the hoster of the TE not to be like messing with the machine. Yeah, so I initially got this grant to actually implement something else. I was supposed to write code that implemented sequencing rules for protecting sandwich swappers. Matthias actually wrote these rules. But the idea is that after you have a starting price in the block, you just like order the swaps around the starting price. And if you follow the rules, then you can like kind of guarantee that users aren't getting sandwiched. And you can modify the auction contracts in the TE to actually like simulate all the swaps to construct bundles where the swaps actually follow this pattern. There's some like overall like UX issues because now you need your swappers to deposit the funds that they would like to swap before they would make the swap. So it's like a two-step, I guess like a UX now. And that's because like you don't want swappers to be able to like revert their trades. Because if one of the swappers like trades like reverts, that just messes up the ordering and like you no longer have the pretty like price execution that was initially offered. So again, just to recap, sequencing rules, protocols specify how they would like to be sequenced, and then we build blocks that respect that sequencing. Again, how to implement this is an open question. These are just like two examples of different rules that could benefit like users. And yeah, so the other main thing sequencing rules might be good for is doing asset price discovery. So let's say that you have a lending protocol and you would like to auction off like unique assets. You can actually run auctions now more efficiently to do quicker price discovery. And yeah, again, my name is Lily. I have socials. If you guys want to talk more or have comments, I'm very excited.
Thank you, Lily. This was great. Do you have any questions for Lily?
Yeah, really interesting talk. Super excited to hear about it. What do you think about these? I mean, you mentioned a number of times UX hurdles, and for me, these types of solutions, like the hardest part seems to be how you pack in the normal user swaps and how they can actually have a nice UX. So as far as I understand, in this case, all the normal users, they need to also send Suave transactions, right? Like they send to the TE first, and everyone gets bundled together.
Yeah, so you send your like you send your normal Ethereum transaction to the TE. It's like you can like have a wrap around it. Like you could have like, I guess like providers who just like reroute. Like you could do it like through like, not directly through MetaMask, but like something that simple. Because you're still just like signing over like an Ethereum transaction.
Okay, so yeah, in this case, it is a fully encoded Ethereum payload just sent to sort of a different domain and maybe wrapped with some other signatures.
Yeah, but the wrapping logic is not specific to the swapper itself.
And in general, do you have any comments on, because I see a number of these types of systems, whether they are an Ethereum transaction or there's some sort of intent-based system, like, yeah, the dynamics around how different versions of these sorts of systems will actually be able to, I don't know, capture a good amount of order flow or get network effects and buy-in to the systems. If it had those network effects, then the thing seems really beautiful to me. But how to generate them is a question that I have, yeah.
Yeah, like I feel like this specific like implementation would be good for pools that experience like a lot of like arbitrage. I don't think this is like a good construct for like pools that like don't experience arbitrage because this is like a huge setup for nothing then. I forgot the rest of your question.
Any other questions?
What happens when
Correct. Yeah, so the auction bundle has to like unlock. Yeah, but like I wrote the code, the auction, so it's like if it sees that it's like a nonce was not incremented, it will like resend the same like user swaps. And also if there's like no like winning bidder, if no one bid it, it's still just like sends all the swaps and like unlocks the pool for the users. So the private key in the swap does have to pay for a transaction for every block. So like I'm interested in like having this actually run on like an L2 that supports bundles or like different chains or different like ecosystems that have like native bundle support. Like I do not think that this is like a proper fit for like Ethereum's like landscape today, unless there's like some like driving reason that you want to run auctions for your users.
Any other questions?
Tell me if I missed this in your presentation, but the sequencing logic, you say protocol can build this. Does that mean that the block builders have sort of like a constraint to follow the sequencing logic that the protocols have put in? And so does it also mean that different protocols can build their own sequencing logic?
Yeah, so the goal is to like, the goal of this like implementation was to be an example of a protocol like owning its own sequencing logic. In this case, the block builders don't have to do anything but like run the bundle. Like if the block builder tries to like take apart the bundle or do something to it, the swaps will just like revert. So this scenario like just like interfaces with the block builders, but like this might not be the best way to actually implement sequencing rules. Like if block builders were like offering this as a service to like protocols, that would be cool. It's like open question on the best way to actually allow like protocols to sequence themselves.
It seems like, I don't know if this could be the future, but really you can replace block builders going forward. If L1 has that kind of architecture, it can integrate
Yeah,
an automated way to sequence.
yeah, like the goal is like, I don't think block builders should exist or have that control. Like I think that's what protocols should be doing. There's issues with like composability and just like, this is like a pretty like EOA centric model. It's not super friendly with like account abstraction or just like I guess like protocol communication.
Any other questions? Yeah, if you don't have any questions, let's thank Lily.